Okay, so again, with the square roots, you want to be careful, okay? You want to be careful. All right? That's what I'm trying to illustrate here. Again, if you take A and B here to be any two positive numbers you want, you would see that the square root of A plus B will not equal the square root of A plus the square root of B. All right. So let's get to the midpoint part. All right, well, first of all, what is the midpoint? Well, if you have 2 points, 2 different points here, P and Q are different now. So if you were to plot them in the Cartesian plane, they would not overlap. Then the midpoint of the line segment, remember if you have 2 different points in the Cartesian plane, right? You can draw a straight line segment connecting them. The midpoint M of that line segment, okay, it's the point on that line segment such that this is true. The distance from P to M equals the distance from M to Q. So again, it's the point M on that line segment such that this happens. Visually, we have something like this. You have P, that's an endpoint, right? You have P and Q are 2 different points. You draw the line segment here, as you can see, drawing this wonderful line segment, okay? And they're 2 different points. You can always connect them by a straight line segment. M is on this line segment. So it's a point on the line and such that the distance, let me see if I can draw it, and such that the distance from, from P to M equals the distance from M to Q. Those two distances are the same. I mean, it's nice though is that there's a formula. Here's the formula down here. Remember, P and it's on the slide already. Essentially, you're taking the average of the x coordinates of P and Q. You're adding them up, divided by 2. Same thing with the y coordinates. That's really what the midpoint formula is. So. Okay, well, let's practice that. So let's find the midpoint of that line segment, PQ. Let's suppose P was the point 1, 4, and let's say Q was this point, 3, 2. What would that point M be? Well, we would have, again, we have our formula, right? So we would add the x coordinates of P and Q, right? We're adding them. Then we're dividing by 2. We add the y coordinates of P and Q, right? That's what this is saying. And then dividing by 2. And so what you get is 4 over 2, 6 over 2, which is the 0.23. I mean, I know I didn't say, well, x sub 1 is this, y sub 1 is this, but just look at what's happening. You're adding the x coordinates and dividing by 2. You're adding the y coordinates and dividing by 2, right? That's all we're doing. And just for practice using the distance formula, let's do this. If you take the distance from P to M, right? We have 1 minus 2, right? Subtract the x coordinates, square, and then square that difference. Subtract the y coordinates, square that difference. Right? We add up those squares. We calculate the squares, we add them up, and then take the square root. So we're going to get negative 1 squared plus 1 squared, and then we take the square root of that sum, which is the square root of 2. Same thing with m to q, right? We have change in x coordinates. We have, in this case, I do 3 minus 2 squared plus 2 minus 3 squared. And again, it really doesn't matter what order you subtract, right? Because you're squaring. You get 1 squared plus negative 1 squared, which is the square root of 2. I know before I said, okay, well, let this be x1, let this be y1. But again, if you look at the distance formula, let me see if I can get back to it. Where is it? Here, in this slide, for instance, I mean, look at what's happening. You're just subtracting one x coordinate from the other, squaring that difference. Same thing with the y coordinates. What I was trying to illustrate here is that it really doesn't matter, you know, what order you're subtracting here. All right. Now here we can see that the distance from P to M and the distance from M to Q, they're both equal to radical 2, the square root of 2. If you were to plot the 3, right, you would have this. So at least you know M is on the line segment containing P and Q. I mean, here I drew the line, but you know, it's the same idea. I mean, there is a way to determine if those 3 points are on the same line algebraically. I know they go into it in the book. I don't remember what you do, but anyway, that's okay for now. All right. So that's one example. Okay. Are there any questions about this? Again, here, notice we're adding. I've seen students in the past, they would subtract. You know, don't do that. You add. So, all right. Let's get another one in. Suppose now, let's do it. So now suppose P and Q are these points. Okay. Well, what would the midpoint be? Well, again, it's just a formula. You add the x coordinates, right? That's what I'm doing here. And you divide that sum by 2. For the y's here, you add the y coordinates and divide by 2. You get this. So here we get 3 over 2, negative 5 over 2. Which works out to be this? And again, I just do, you know, over here, just like with the other example, we can confirm it. So we'll see. We're running low on time. We'll start from this slide next time. I really want to go through the distance part because it gives more practice. So let me stop the recording.